Let me start recording first. Okay, so lab 4, we are actually doing on your one sample test. Now, in Excel analysis 2 pack, there is actually no ability to do one sample test. That means your one sample Z test and one sample T test. But we can kind of trick the system into doing it. So I'm just going to show you how we can do that. So for this, I will need some data. Let's say I will take your height. Okay. I'll just go down. You kind of tell me what is your height in centimeters. Okay, so Charles, what is your height?
180.
180. You're tall. Jermaine?
160.
160.
Yeah.
Okay, Damien?
170.
170. Okay, we'll just randomly pick a few more. Jordan?
170.
170. Okay, Minhui?
Around 172.
172. Okay, you're quite tall. Lucas?
165.
165. Okay. Jingru?
Around 151.
Around 151. Okay, Ryan?
Around 165.
Around 165. How come you're around? You don't know your height? Okay, Sixian?
169.
169. Jingyun?
163.
163. Jolene?
153.
153. Okay, Trevor?
173.
173. Xavier?
180.
180. Okay, so we have this height. Okay, so what we want is, assuming that I want to test the null hypothesis. Null hypothesis that the average height is, let's say, based on estimation is maybe 170 cm. Okay, so I want to test this hypothesis. How do I do that? Let's say if I were to do, okay, hold on, let me get this out. If I were to do, there are actually 3 ways. So I'll show you all the 3 ways. Method 1 is to do a Z test. This is by formula. By formula. So by formula, this is actually equivalent to your 2.2. Okay, so in the lab, it's actually 2.2. So section 2.2 in lab manual. Okay. The second method is to do Z test using your what do you call it, data analysis. Analysis 2 pack. So this is equivalent to yeah, also about 2.2, about step 5, task around task 5. Okay, so the steps is given in task 5. So here I put steps in task 5. Okay. The third method will be your t-test. Test, again, you'll be using your data analysis. So the steps is also given. The steps is given in 2.1, section 2.1. Section 2.1. Okay. Let us do one at a time. How are you going to do that? Okay. The simplest is your 1. Okay, so let me do, this is the simplest. So how do you do that? When you do your tutorial, you'll find that you actually always have to calculate T statistics, Z statistics, then you go to a table. But when you use Excel, it will give you the p-value directly. Okay. So this is how it tends to look like. Bird, where's my bird? Bird. Okay. So let's say when you do stats by hand, okay, what you tend to do is you will calculate the statistic. Okay, so this can be your Z value, can be your T value, and so on. Okay, then after that, you find the critical value. Okay, so critical value is found using your alpha equals to 0.05 or 0.025 or 0.01, depending. Then the third step is you compare the statistic with the critical value. Make sense? So this is what you have. Now, essentially, these critical values, what do they really mean? This is like the probability value, the p-values. So this is the p-value for the respective critical values. But when you do your stats by Excel, okay, although it calculates the statistic, but this is actually quite so it still calculates a Z value, P value, and so on, or Z value, T value, and so on. Okay. But what it doesn't do is it goes to the next step. It takes the statistic, okay, which is a Z or T or whatever, and then calculates the P value. So this P value is the probability that your null hypothesis is true. Make sense? Then what you do is you do your interpretation. Your interpretation is what? If the p-value, if the p-value is less than your alpha, it's the same alpha here, the same alpha here. If the p-value is less than alpha, then you say that you reject your null hypothesis. Basically, the probability of a null hypothesis being right, being true, is less than 5%. If the p-value is more than alpha, means you fail to reject your null hypothesis. So far, do you get the difference? Anyone do not found the difference? The reason is this: when you do stats by hand, the statistics table does not calculate every single p-value for you. So you actually need a threshold to actually help you. Okay, but when you do statistics with Excel, you calculate the p-value for you. Then we use the p-value to determine what is the likelihood that the null hypothesis is true. So we actually, this idea, there's a reverse there. Okay. So we'll look at that. So how do you do by hand? Okay, so I give you a few seconds or few minutes, 1 minute or so. Type this out into your own Excel spreadsheet, your own height. When you're ready, then you kind of show me your hand. Okay, so let me just calculate the mean height, and okay, the mean height will be average. Okay, and then I calculate the standard error. Standard error will be the standard deviation divided by square root of the number, so count. So that is the standard error. Okay, Sixian, are you all right? Okay, so
Okay.
put down all your hands. Okay, so you calculate the standard, the mean is actually 167. So I want to find, is your height actually average height different from 170, 167, and the standard error, which is the denominator. Let me just use Excel. How should I do that? Doesn't matter. Let me just use this. But I need this later. Okay. So okay. So when you calculate the Z value, you have the average minus the mean. Here I always tend to use absolute, divide by the standard deviation over square root of n. This denominator is what we call as the standard error. Okay, so that's how I get the standard error here. So I take the standard deviation, divide by the square root of the sample size. Okay, so I get 2.46. Okay, then how do you actually do step by formula is, this is the p-value. So what I did is, I use this equation or this formula known as z-test, z.test, open bracket. Okay. Then the first one is the array. Array is the data that I want to give it. So I give it the array data. The next one is x. What is x? X is the item that I want to test for. So item is the data is 170. If sigma is not given, it will use the sigma for here, the standard deviation for here. So that gives me the p-value is this. So do I accept or reject the null hypothesis? the p-value is 0.88. So since Ryan has not put down a hand, Ryan, so do I accept or reject the null hypothesis?
Not quite sure.
Not quite sure. Go back to this. Okay, so here the criteria is this. Criteria. Okay. If the p-value is more than the alpha. Okay, so the alpha can be usually is 0.05. Okay, can or 0.01 depending. If the p-value is more than alpha, you say that you fail to reject null hypothesis. Reject null hypothesis. Hence, you accept the null hypothesis. Because if the p-value is more than alpha, means that the probability of the null hypothesis being right is more than 5%. So on the other hand, if the p-value is less than alpha, that means the chance of null hypothesis being right is less than 5%, you reject null hypothesis, and therefore hence you accept the alternate hypothesis. So based on this p-value, do you accept or reject the null hypothesis that the average height is 170? Try again, Ryan.
You accept because it's larger than 0.05.
Yeah, so you fail to accept. So conclusion is you accept the null hypothesis. Right? So why not, at this moment in time, based on what you have done for your tutorial, can you actually calculate the Z value? You have these numbers, right? How do you calculate Z value? Can someone calculate for me? Let's have Jermaine. Jermaine, can you calculate Z value? Just use your calculator or whatever.
Hold on.
Yep.
The SE formula again, I missed it.
What SE formula? SE formula, Lisa?
Yeah, thank you.
I got negative 4.55.
Negative 1.55.
4.55.
Negative 1.55. Okay. How do you actually write?
The formula is for Z is the sample mean minus the
Okay, so what minus what? What do you have?
167 minus 170.
0. Okay.
Divided by the standard deviation divided by the square root of the sample.
So what do you use for standard deviation?
2.46.
This is already the whole denominator.
Oh, okay.
Yeah, this is already the whole denominator. Because see, it's already a standard deviation divided by square root of n.
Okay, my bad. Then it's negative 1.21.
Yeah, negative 1.21. But I tend to, your tutorial lecturer will tend to tell you that you do an absolute first. So it converts the negative to positive. Okay, so it's 1.21. Now, if you go to your table and look for 1.21 or 1.22, see what do you get? Let's say if you go to your tutorial, no, not this tutorial, all over the place. Okay, hypothesis testing goes. See, let's go to your today's tutorial file. Okay, tutorial file. Okay, so say here. Okay. 1.22. Okay, so what do you get? 1.22 is this. Okay, so you get this value. Now, if the area, that means the shaded area is 0.1112. So what about the non-shaded area? What about the non-shaded area? The non-shaded area will actually be this value. Okay. So indirectly, returns the one tail p-value. So here, in order to do that, you have to take 1 minus this value. So this is the one that you get from your table in itself. Okay, so for in order to do that, you have to just minus off. Okay, if you do a calculation this 1.22 and then you calculate, because the critical value is 1.96. Okay, so this is one way of how you calculate by hand. Okay, this is one method. Now, however, we skip 2 first and we go to 3. How to actually do t-test? Because since this is less than, there's only 13, it's less than 30, and you do not know the population standard deviation. So how do you do a t-test? Excel doesn't have a t-test for one sample. Okay. So if you read the description, Excel doesn't have a t-test for one sample, but you can actually kind of trick Excel to do it for you. Okay, so how to trick Excel to do that for you? Simply, you have a height. Then you actually need another column called your, let's say we call it dummy value. Dummy value, you put everything to be 0. Okay, do that first. We have 2 columns here. One, your actual height, one is your dummy. If you're done, just raise up a hand as well. Otherwise, I do not know. Damien, Sixian, Trevor, Bernice, Qing Xiang. Qing Xiang, are you there? Okay, good. Okay, I'll put down your hands. Okay. Now you just see how I do it. Okay, I'll do it step by step. You see how I do it first. Okay. So I will go to my data analysis. Okay, so let me just go here. I'll go to my data analysis. And for this, I have to use t-test 2 samples assuming unequal variance. Okay, I cannot use the rest. I have to use assuming unequal variance. Okay, so far? All right. Then I click OK. You give me this table. So let me just delete everything first. So this is how the original data will look like. Okay. So range 1, I just highlight the height. Okay, including the labels. So it's from B1 to B14. Range, variable range 2, I highlight my dummy variable. Then because I highlighted the labels, I click on these labels, click it on, tick the labels. My hypothesized mean, this is where I want to put down my value here, 170. So it's 170. Okay, it's a value I want to test. This is the sigma that one. This is the mu that I want to test. Output range, just put an empty cell. Then you click OK. So you will generate the result for you. Hello, it did. So you generate the results for you. So this is the data. The mean of the height is 167. The variance is 78.8. Anybody know what is variance? You've seen that in your tutorial already. Can someone tell me what when you square root of variance, what do you get?
Xavier here, you get the standard deviation.
Yes, you get standard deviation. Okay. Here, observation is 13. Make sure you highlighted 13. The hypothesized mean difference.
Sir, I don't have the data analysis.
Do you have that last week?
Yeah, I did.
Okay, so go back and activate it. Oh, you forgot how to do that.
I forgot I'll do that.
Okay, make sure you remember. Nobody can help you in your test. You go to File, Options. Go to File, go to Options. After Options, go to Add-ins. Then you go to Manage Excel Add-ins. There's a Manage Excel Add-ins. Then you click on Go. You pop up this. So you click highlight the Analysis Toolpath, Analysis VBA, and Solver Add-in. Then you should pop up.
Okay, go to add-ins, then what's the next step?
There is this Manage Excel Add-ins, and there's this Go. You can't see it very clearly. Can you see that below?
Yeah, can.
Okay, click on it.
Sorry, Che, do you mind going through the t-test again?
Okay, hold on. One step at a time. Okay. All right. So the t-test, let me just repeat it again. Left, up. Okay. So the t-test is how you do it. You go to data analysis. Use the t-test 2 samples assuming unequal variance. Make sure you choose unequal variance, otherwise you get a wrong answer. Then click OK. Range 1, you highlight the height. Range 2, you highlight the dummy column. Okay, because I have the labels, so I tick the labels. My hypothesized mean, this is actually the mu that I want. My 170, the one that I want to test. Then my output range, just put any output range. After that, just click OK. So you get this value. So do you get that? Okay, all of you try this. Make sure you get this result. Okay, if you get this result, then you can raise up a hand as well. Yep. You know how I do it already. Once you get a result, you raise up a hand.
Wait,
Check
sorry,
your result.
output range is what again?
Output range is just an empty cell that you want to put the table in.
Oh, okay.
Hello teacher, can you click on the Z value?
What's your value?
The Z test result.
This one?
Yeah. Thank you. Okay, thank you.
Umara, Wenjie,
Sorry, can you show the z-test again?
What's Z test again? Which
The
one? The P
z-test.
value or the Z value?
Z value, Z value.
Yeah.
Thank you.
Okay, so you can put down all your hands already of done that. Okay, so the question that I want to ask you is, when I do this test, is it a one-tail test or two-tail test? Wenjie, what do you think? Is it one-tail test or two-tail test?
Two.
Two-tail, right? Yeah, because it may be more or less than 170. So it's two-tail test. So here what we need to look at is this value here. This is the p-value that the null hypothesis is correct based on the two-tail test. Okay. So in this case, what it really means is there is 24.65% that the null hypothesis is true. So do you accept or reject the null hypothesis here? Let's try Jingru.
Sorry, can you repeat your question?
Okay, so based on my T statistic, my T test, there is 24.6% chance that the null hypothesis is true. So do I accept or reject the null hypothesis?
I'm not sure.
This. Look at this.
Okay. It's fail to reject.
Fail to reject? Yes,
Fail.
correct. So you fail to reject your null hypothesis. Hence, you accept your null hypothesis. Therefore, the average height is 170 cm. Okay, right. So you only reject your null hypothesis if this value is less than 0.05. Okay, so far? All right. Now, since you are able to do that, why not you try it out yourself? Okay. Try task 2 yourself. So you have 15 subjects, males and females, but you test at 5% significance that the heartbeat, mean heartbeat is 70. So I don't care whether male or female, just lump them together. And this is the p-value. See whether you can get this p-value. Do that. Ow, my leg. Ouch. Okay, so I have my answer. If you have the correct same answer with me, then you raise up a hand. So this is the answer inside your lab manual, 1.244, which is this. Okay, keep your hands up. Since you're not using any muscle strength at all.
Sure, how you know it's two-tail?
No, it's two-tailed because your question is really asking you if you never say, then the mean is 70. If you never say, it's usually two-tailed. If you never say it's more than 70 or less than 70, then it's usually two-tailed.
Oh, okay, thank you.
Next time when you say something, tell me who you are, okay? Okay, once you get the answer, make sure you raise your hands up, otherwise I have no idea. Okay. So in this case, you also cannot reject null hypothesis. So here is you fail to reject your null hypothesis. Because you fail to reject, it means that accept a null hypothesis. That means that the mean heart rate, mean heart rate equals to 70 beats per minute. Zul, are you okay? Okay. All right. Put down your hands now. We'll go to the next one. Okay. So we practice another one. Now you have to open up your diabetes data set. Do you have that? Okay, you should have a diabetes data set. And what we want is this is glycosylated hemoglobin. Okay. Now, based on the description, the glycosylated hemoglobin is the amount of blood glucose that it's a measurement of the blood glucose. Okay. So the reading has to be lower than 7. You want to check is the reading actually lower than 7 or not. Okay. So what you do is you take the whole glycosylated hemoglobin. There is 398 plus the header is 399. You see the average is 5.6. So you want to do a test that the glycosylated hemoglobin is actually lesser than 7. So why not you try out? Here, what is the null hypothesis? Can someone tell me what's the null hypothesis and what's the alternate hypothesis? Let's try Shiyun. What is the null hypothesis?
That the mean is 7.
Null hypothesis is the mean is 7, right? Now, here. So the null hypothesis is that average glycosylated hemoglobin (HB) equals to 7. Okay, alternate hypothesis means it's not equal to 7. So why not you do the test yourself and see whether it's just repeating the same old thing all over again. See whether do you get the answer. Is this a one-tail test or two-tail test? Lucas, do you think this is a one-tail test or two-tail test? Read the question. Do you think it's a one-tail test or two-tail test?
Two. Wait, one.
One-tail, right? Okay. So basically, is lower than 7. So the alternate hypothesis is the average glycosylated hemoglobin is actually lower than 7. So in this case, what you need to take is take the p-value for the one-tail test. Not the p-value for a two-tail test, the p-value for one-tail test. Okay, try this out. If you get the data, if you get the results, then again raise our hands.
Sure, Wen-Jie here. For one-tail test, you also use the same format.
Correct. You just read the different row. Two-tail test, you read this. One-tail test, you read the highlighted one. Okay, Jolene, Jordan, Yamamura. Saki. Okay, okay.
Saki.
Saki, okay. Saki, I try to remember because your name is inverted here. Okay, it's in row. Okay, all right. Okay, you can put down your hands. So this is exactly how you do it. Now we then go to the next one. Okay, you can do tests for yourself. See whether do you get this p-value. That means it's a waistline below 40. Okay, so 40 for the waistline is this where on earth is the waistline? Yeah, this waistline. Try out yourself, see whether do you get there. So it's keep drilling the same thing. Okay. Test whether waistline is below 40. So same all over again. Ask for okay, so let me just get the results out for you and then you can compare against my results. Okay, by now you should be quite familiar already.
Do we need to write about the null hypothesis for this one?
You can, but I just kind of put it, just I didn't bother to write, but you know what? You should have write. Okay, similar once you're done, you know, you can raise up your hand already. So you reject the null hypothesis as well. Okay, Xingyun, Trevor, and Zul, any issues here?
Don't have.
Okay, Xingyun, are you alright?
Yes.
Okay, alright. So basically, you keep trying, keep doing it. Okay. So we have already done this one sample t-test, the one that I showed to you. Now, I leave it up to you to go and do your task 5, your tutorial question 9. Let's say tutorial question 9, where on earth are you? Tutorial question 9, tutorial question 9. Okay. Tutorial question 9. 8. Okay. So tutorial question 9, you can do this as well. Okay. Is the generated number that is 50. So you can actually do that. Claim that it's 50. So let's try this out. Okay. So you want to check, is this row of numbers 50? Okay. So this is we have already done this in this step. Okay, using the same equation. So your p-value. Just do a z-test yourself. Okay. Tutorial 50. How do you recover? Okay. More than 50 minus 2. Okay, I write something wrongly. Got 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can get the z-test. Basically, what you can do is you can do step by step if you want to. Okay. So from here, you can calculate the average. Okay. So you get the average, the standard deviation. So then you have the standard error, which is your standard deviation divided by square root of 2, 4, 6, 8, 10. So the square of 10 to get this. And your z value, z statistics, is your this minus 50 divided by your standard error. Yep. It's known that the standard deviation of the machine is 10.2. Okay, so 10.2 you don't, so you actually use this standard deviation is 10.2. Okay, so you get that. Okay, then your this is a z value, then you can calculate your p-value, which is, remember, we use the
Sorry, can you show
inverse.
about the SE for a moment?
Hold on. Let me just finish it first.
Okay.
SE for a moment. Probability, fusion. This mean is 0, 1. Which one? This SE. Yeah. It's just a standard deviation, which is given in the question 10.2. you divide by the square root of the numbers here, the 10 numbers, square root of 10. It's a bit artificial, yes. Then you get 0.001. So which is, you'll get it here. Okay. So basically there is about 0.1% chance that the null hypothesis is true. Okay. Alternatively, you can actually calculate directly based on the equation that we have here. It's also possible, just a little bit more tricky to do. To do a z-test. Okay. Okay. You want to test the x, which is 50. Then you want to test the sigma. The sigma is standard deviation, it's 10.2. They give you the same answer.
Hi, Cher. If we leave the sigma empty, right, they will use the sample standard deviation, right?
Yes.
Okay, thank you.
But here you cannot use the sigma empty because the sigma is given in the question already.
Yep, yep.
Okay, in real life, we almost never use that test. In real life, we almost never use that test. In the event, okay, this is out of this syllabus, but in the event that you can use that test and you use a t-test, it's still okay. But when you're supposed to use t-test and you use z-test, you're going to get very wrong. That's why we always use t-test. We almost never use z-test. Okay, so this is just an example to show you how it can be done. Anyone up to here have any problems?
Sorry, can you show the p-value?
Which p-value? The two of them.
The first one.
This one or this one?
Yeah, the first one. Yeah, this one.
Xavier here. May I ask how do you get the z value again?
The z value, use the equation of. See this z value is just this 59.7 minus 50 divided by the standard error.
Oh yeah, okay, I get it. Thanks.
If you don't get this, how on earth you get for your question 9? This number here. The same, huh?
Sorry, can you show the z again? I missed it.
Yeah. It's actually the equation. How do you
Okay, thank you. Hang on.
Sorry, can you show the other p-value?
This law? Because I want to use the standard deviation that is given in the question. That's why I have a third part here.
Hi, Cher. For the p-value, right, we don't need to use, we can just use this one, right, which is the z.test, then use the array. We don't have to use the normal distribution, then 1 minus, right?
Don't have to, yes. But you see, the problem is this. If you use this, okay, if you realize why do I use a z-test here and then I use 1 minus, for this one. You know the difference or not? Here I use 1 minus, and here I use the z-test itself. Anyone knows why? Anyone knows why here I use 1 minus the value, and here I just take the value by itself?
Because the normal distribution is the white side, then the blue color one is this value.
To some extent, correct, but it is actually not precisely correct. Okay, because here is to calculate the inverse. Okay, this is the area. This is the area of the white side. Make sense? That because it's cumulative, this is the area of the white. This white area. This formula, the normal dot distribution, is to calculate the white area, which is essentially the white area. So I got to use 1 minus the white area to get the blue area. While for the z-test itself, it gives me the blue area already. Okay, who asked the question just now? Or who talked just now? Okay, the rest, all right.
I can't do the other p-value. It says there's too many arguments in the function.
Which one? They are doing my B7 or C7?
C7.
C7. There's only 3 arguments. How many arguments do you have? It's A1 to J1. It's not A1 comma J1.
Sir, Damien here. For the z-test, right? What is x again after the array?
After the array, this is the value that you want to test. The value that you want to test.
The value, okay. Thank you.
So you go to x there. This is the value to test.
Oh, okay. Thank you.
Okay, the rest, are you all right? Charles, half the class. Half the class has not raised our hand.
Not. Can you show p-value again? Sorry.
Which p-value? There are 2.
The B.
This one?
Oh wait, how do you get the SE?
SE?
Yeah.
Standard deviation 10.2. Okay, SE is essentially this guy is your SE. The denominator, this is your SE. Who is that just now?
Yeah, me, Wenjie.
You get it or not?
Wait. Can I see your answer? Oh, okay.
All right, the rest. Jordan, Lucas, Jingru, Jingyun, Jolene, Bernice, Jinxiang. Okay, raise your hand, otherwise I do not know. Cannot see whether you're done or not. Have you all been to school this week already? Or been to campus this week?
Not yet.
Speak louder, leh.
Don't have.
Not yet, okay. I'm just wondering how is things there. Do you have any friends who are year ones this year?
Yep.
How are they finding things?
Very difficult.
You mean the home-based learning or this week? It's very difficult, or both?
I'm not sure. He just say very difficult lah.
From which school?
MBT also.
Oh, okay. Yeah, it can be difficult, especially this week. It will be very difficult. Imagine during your time you have orientation camp and all this stuff. For the current year ones, they're essentially like 200 headless chickens running all over the place, not knowing where all the labs are. Okay, Jordan, you're fine or not? Jingyun? Jingyun.
Yes.
Okay. Then raise your hand lah. Okay, then put down all your hands. Okay, so what we have, if we go back to the height problem again, we have done 1 and 3. Okay, so our own thing is 2 we have not done yet. Now, because it's even trickier to do, let me show you how we can do 2. Okay. I'll just collapse this guy here first. How we do 2. Okay. So I want to do this. Now, it's trickier because if you go to the data analysis tab, you go to the last one, t-test 2 sample for means. It's a way that we can trick Excel into doing it. How do we do that? So it starts off with something that looks like that. Okay. So again, variable 1, variable 2 range. I will just take it. Variable 1 range, variable 2 the dummy. Hypothesized mean is 170. Okay. What I need is variance. So this is a bit tricky. What on earth is my variance? And it actually forced me that I need some variance. So the way to do that is I have to calculate the variance for height. But what is the variance for dummy? Makes sense, right? What on earth is the variance for my dummy? Okay. So how do I do that? First, I need to calculate the variance first. So variance is, the function is called var. Variance sample. So this is a variance. And if you calculate the variance for the dummy, you find that it is actually 0. But you know that 0 is a very dangerous number. Okay, because things divided by 0 is infinity. So what you need to do is you calculate the variance, the known variance for the data 1 range is actually the variance that I calculated. So here you have typed in yourself 78.83. While the variance 2, the dummy variance, you give it a very tiny number. Let's say 0.001. Okay. Then the output range, just put on some place. And then output range contains one data point. Range, what on earth is it talking about? Mean contains input range contain one sample. Yeah, I did. Oh, okay. Select the wrong thing. So then this is my data. Okay. So it is actually not easy to get Excel to try to do your t-test, your z-test with only one sample. Okay, but if you want to do that, you can. Okay, so this is just to show you that it can be done, although it's not easy to do. Okay. All right. So far, any problem?
Oh, hi, Charles. How do you
Yes.
get variance again?
Variance, you mean this one? 78 point something. Is it, how do you get 78 point something? Is that your question?
Yes.
Okay. Just this formula. VAR.S. That's variance.
Okay. Thank you.
Otherwise, you can just take standard deviation times standard deviation. Okay. So that's all for today, actually. Any question how you're going to do it? Okay. Whoever just now that forget how to get the data analysis step, please make sure you know the steps. Okay. Think about if you open your Excel sheet and then without that, for your online quiz or whatever thing, nobody can help you. So far, so good?
Richard,
Yes,
today no attendance.
Okay, so what happened is today our dearest attendance system refused to let us mark. So let's see. How can I mark your attendance today? Let me just think of a better way. Okay, let me just go back, see whether my attendance can work or not. Forms. That gives me some errors. Okay, now it works. Okay, just now it refused to work. So let's say today is PDA, PM 5. Okay, so today is what date? 4 June 2020 attendance. So I will say this is 6/4/2020. Okay, just now there's an error. Okay, you get my attendance now. So when is the first time that you need to go back to campus for this semester?
August.
Next term.
Next term?
Yeah.
Next term or next semester? Next term, right?
Yeah, next term.
Okay, that's good. That's good. Well, at least it's better than the year ones, which they do not even know who their classmates are. Okay, so yep, really that's all for today. Any other questions? Okay, speaking of which, where am I? Okay, your two hands are still up. Okay, I give you a choice. Do you want myself out?
Yes.
Who's that guy? Yes.
Yes,
Me.
please.
Yes,
Who's
please.
you? Can you say your name?
Jordan.
Jordan. Okay. Let's see. One sample t-test. Lab 4. Okay. Fill your counts here. Okay, you go and collect it. So how do you change photo? That's one. Charles doesn't look like that for sure. Jolene obviously doesn't look like that.
So what do you mean? That's me.
Huh?
That's me. Yeah, that's me.
Yeah, I know. What do you do to change your photo?
Just go to the settings.
Okay. Why do you choose this photo?
Because it's me.
It's you?
Yeah.
Okay. Not so beardy at least. Then Jolene, why do you like this photo?
Cause Jolene gave me that sticker.
Oh, okay. All right. Okay. Any other questions? Otherwise, that's all for today. That you need to ask. Apparently, most of you did pretty well for your online assessment. That's good. Okay, nothing else? Okay, that's all for today. Can go and take a rest for next class. Bye-bye.
Okay, thanks.